Another theorem in algebra is called the factor theorem. The factor theorem gives us a way of finding out if x minus r is a factor of a polynomial by evaluating the polynomial at that number r. So here the factor theorem stated out says, if p of x is any polynomial, and let r be a real or non-real complex number. So this also works if you have i's in your numbers that you're working with. Then if p of r is equal to 0, so if you take out the x's in the polynomial and put the number that follows the minus after the x through the polynomial, and when you evaluate it you get a 0 out, if that's true, then x minus the r is a factor of the original polynomial. It also says that if x minus r is known to be a factor of the polynomial, then you're guaranteed that if you put that r through the x's in the polynomial, you'll get a 0 out. So this will help us a great deal when we're trying to factor polynomials degree 3 or higher, or when we're trying to look at solving polynomial equations degree 3 or higher. It also can help us graph polynomial equations y equal p of x, because the value of r that put through the polynomial gives me a 0 out is actually the x coordinate of the x-intercepts. And those are also called the zeros of the function. So it can help me find the zeros of the function, or it can help me use the zeros of the function to factor a polynomial. So a ton of different applications for the factor theorem. Let's look at a couple examples so that we understand the theorem a little bit better. So this says, determine if the following is a factor of the polynomial p of x equal x to the third plus 3x squared minus 13x minus 15. And if so, find the other factor. Well, our first one is for x minus 3. So remember, it's x minus r. So x minus the 3 is what is following the minus. So in this first example, r is 3. So we're going to evaluate this polynomial by taking all the x's out and putting 3's instead. So p of 3 is 3 to the third plus 3 times 3 squared minus 13 times 3, and then minus 15. Now remember, when you're evaluating the polynomial and you're running the numbers through the x's, you need to follow your order of operations. So you need to do the exponents first. So 3 to the third is 27, plus 3 squared is 9, so I go 3 times 9, minus 3 times 13 is 39, and then minus 15. Now 3 times 9 is 27. 27 plus 27 is 54. 54 subtract 39 is 15, and 15 subtract 15 is 0. So p of 3 comes out to be 0. So since p of 3 came out to be 0, that means that x minus 3 is a factor of that polynomial p of x. And the way I can get the other factor is by synthetic division. So if I take and do synthetic division, remember 3 is our divisor, so we'll put that in a little half box. And then we want the coefficients of the variable terms with having those in descending order. So power of 3, power of 2, power of 1, power of none. I have it in descending order and none of them are skipped. My coefficient in front of x to the third is a 1, so I'll go 1, and then 3, and then negative 13 and negative 15. Go down and draw a horizontal line. So bring the 1 down without doing anything to it. 3 times 1 is 3, and 3 plus 3 is 6. 3 times 6 is 18. Negative 13 and 18 is 5. 3 times 5 is 15. And negative 15 plus 15 is 0. Remember, that last number is our remainder. So we have a remainder of 0, which is exactly what this was telling us, is the remainder is 0. And if the remainder is 0, what we divided by is a factor. So our x minus what we divided by 3 is a factor. X minus 3 is a factor. And the other factor we get from the bottom row of the synthetic division table. So remember, it's in descending order, and we started with an x to the third and divided out an x to the first. So the highest power on my quotient is going to be an x squared. And reading it in descending order, that means I have 1x squared plus 6x plus 5. So then that's the other factor. The other factor is x squared plus 6x plus 5. Okay, now let's look at part B. We want to see if x plus 2 is a factor. And let's actually write this closer to the question. So x squared plus 6x plus 5 is the other factor. All right, so let's go back to x plus 2. Find out what we need to plug through the polynomial. Well, x plus 2 is x minus a negative 2. So you're going to put negative 2 through the polynomial. So that's negative 2 cubed plus 3 times negative 2 squared minus 13 times negative 2 and then minus 15. So that's negative 8 plus 3 times 4, and then negative 13 times negative 2 is a plus 26, and then minus 15. So I have negative 8 plus 12 is 4. 4 plus 26 is 30. 30 minus 15 is 15, which is not 0. And since I didn't get a 0 by running negative 2 through the polynomial, then x minus negative 2 or x plus 2 is not a factor of the polynomial. So this one is no, it's not a factor.